In this video, we are going to look at the idea of limits. So which of the following statements about the function y graphed here are true? And which ones are false? So when you're looking at a function, we need to look at a function as when you look at a graph of any function, it should tell you so much about that function. Okay. So if you look at option A, option A is saying is the limit as x approaches 1 from right, that plus means from right of f of x equal to 1. As x approaches 1 from right, is the limit of the function equal to 1. So now we go to the function and look for the graph that is there. So okay, so if you look at the function, the way it has been graphed, if you're going to 1, okay, if you're going to 1, so say 1 is here. If you're going to 1, we see a line moving from 2 going to 1. Like that. The question is simple. Is that line moving to the value 1 for f? Remember, the f we are dealing with f of x. So this f of x is actually the y value. It's a y value and not the x value. The x value goes in the function where there is x. So now, as x approaches the value 1, is f becoming 1? Is the question here. But what is happening is that the red line is sitting on the x-axis all the way until it reaches 1 from the right side of 1. So it's not showing any signs of wanting to become 1. It actually goes all the way at x equal to 1. It's actually becoming 0. It's sitting as 0. It's a constant 0 on that line until it gets to 1. So it means that the limit as x approaches 1 from right of the function f is actually equal to 0. Because we all know that on the x-axis, y is 0. And the line is sitting on the x-axis. So y is 0 there. So it means that the first statement is false. Let's go to the second statement. It's saying, we are now on B, the limit as x goes to 0 from left for f of x is 0. Let's see if it's true. As x goes to 0, so x is here. It's going 0. Remember, x is 0 on the y-axis. So as x gets closer to the y-axis, it's becoming 0. The value of y, it's coming down all the way up to 0 as well. It's coming down via this line. Okay? So it's slowly getting to 0. It's slowly getting to 0. Until if you continue going at 0, it's actually 0. So this one we have proved it. It's true. It is true. The limit as x approaches 0 from left is 0. Then they want to see if you understand what you're doing. They come and say, is the limit as x approaches 0 from left equal to 1? Is it? Yes. Okay, we have different limits as x approaches 0. We already found from left it's 0, so it can be 1. The other question is, oh, I think here you wanted to ask. I think here it would be a bit soft illustration. By editing it, we put a plus. I think the idea was to ask as it approaches 0 from the right. And the question should look like that. So, as x approaches 0 from right, okay? So x is approaching 0 from right. So what we see is x is sitting on the, here it's going there, and the function is coming down to becoming 0. So it's not 1, it was supposed to be 0, so this is false from right. Okay? So we need to find the limit. The limit as x approaches 0 from right of f of x. And from analysis of things, the limit is actually 0 there. So you're looking at what the red line is going to as x gets closer to 0. What's the behavior of the red line? That's the key thing that we're looking at. So the line is going also, the curve, it's getting to 0. So we have the 0 there. Then D is asking us to say, from observation, is the limit as x goes to 0 from left equal to the limit as x goes to 0 from right? Yes. They are equal because we have found 0 here. We have found 0 there. Though they gave us a wrong one here, but we know the correct one. So if we use the correct one, they are equal. And remember our agreement, we said if the side limits are equal, it means that the limit exists. It exists and it is equal to 0. Right. Okay, so the condition we gave for the existence of the limit, we said, oh, the limit will exist. Remember when we talked about continuity, we said the limit will exist if the limit from left and the limit from right are giving you the same value. Okay, let's go to G. Is the limit as x approaches 0 of f equal to 1? We said no. It's not true. Let's talk about other things. The limit as x goes to 1 of f. Let's check now. As x goes to 1 of f. Now here, before we can answer this question, we need to know the limit as x approaches 1 from right. Remember we found it? We said from right, it's what? So we said the limit from right, we found 0. So from right, it's 0. So we also need to find from left. So the limit as x approaches 1 from left of f of x is equal to 1. So you just go to the graph. So x is going to 1 from left. So it's moving like that. And what's happening to y? Y is increasing, going all the way up to 1. Even if it's open there, that's where it was going. So it's 1. When we come here, the limit as x goes to 1 of f, it cannot be 1 because the two side limits are not equal. So this is false. Yeah. This is false. Okay. This 2 is false. Because the limit as x approaches 1 from left has been found. We found it. From left it's 1. So why is saying does not exist? It exists. What does not exist is the limit as x approaches 1. If you take the sides, it will exist.
Sir,
Hello.
sorry, I've got a question here on the same function A. Yes, at the limit as x approaches 1 from the right, let's say maybe I'm starting from 2 here, coming towards 1. As in for me here, it is showing that at 1 from the right, it is at 1. The y value is 1 when x is 1 from the right. Even as I come from the left, it's at kappa 1, but the y value is still 1. Mind, how are you getting the zeros up from the right, coming towards 1 as the x value?
You've seen it, graph. As you approach 1 from 2, is this line that is sitting on that interval going to 1? The y value?
No, it's going down to 0, but
No, it's not going down. It's flat.
It's flat.
It's
yes.
Like
it's sitting on the x-axis.
So it's sitting on the x-axis. What's the y value on the x-axis?
The y value is 0 at the x-axis.
So that's what I'm saying. As x approaches 1 from 2, which is from right, the y value is 0.
Also, we don't consider like exact at 1 when x is 1, because exact at x equals to 1. I'm seeing the open point there.
The fact that that thing is open there, where is it closed?
It's closed at -1.
No. There's a line that is closed at 1, at 1,0. You've seen this line? This line, the red one.
Yes.
It's closed.
Okay, yes.
So when x is 1, it's closed. And it's closed on the same point 1, comma 0, meaning that the y value is 0.
Okay. So yeah, okay. I'm able to see it now. So we don't consider like that top part.
So what we mean by approaching, when we say x approaches 1 from left, x itself is going to 1, right? Then you observe what is happening to y. Where is y going? Y is going up. It's going up. It's going up. It's going up until closer to what? To 1. So you don't have to jump. You have to move with it. You need to go there slowly, until you are closer, if possible, reach there. So if you're coming from the right of 1, there's no, we needed something like this. But it's not there. Or if the line was here, but it's not there. It's down. Are we together?
Clear. Clear.
Okay. So, what about the limit? That's what we know about.
I wanted to say that if I'm not clear, I'm a bit lost.
Where exactly what is confusing? How the lines move, or how we are concluding?
I would say how everything is being done right now. Why it's forced and issue.
So look, let me demonstrate something. If you have this. If we say there's some curve, we put a curve there. We put another curve here. Like that. We close, we open, we close. If I put a number 1 here, I put a number 2 here. I put a number -3 there. When they say find the limit as x approaches 1 of the function f, how many options do you have? How many rods, if they were rods? Suppose we call these rods rod A and rod B. Okay, maybe let me try to assume that there's some plane here. Okay, so it's moving. It will drop people here. Then it will come back and drop some people here. Say it has dropped P and Q there. The target is that these guys should go to C. Okay. They should go to C. Where C is this one, the one. If you are dropped at P, which route is an option for you to go to C? is it possible to move if they drop you at P? Is it possible to use road A? Very impossible.
No.
So the only route you have if you are dropped at point P is to use road B. Okay, if they drop you at Q, you need to use road A to move to C. Now, those roads that are there, in terms of limits, we say, okay, if I want to go, I want to see what happens as one approaches, as X approaches 1. You are seeing what could happen to those people who drop at point P. How will they move to C? How will they move to 1? Okay, what if some drops at Q? You also need to know how they are moving to C. If when they move to C, so you see, if this is a hotel, suppose there's a hotel there, there's another hotel here. This hotel you are paying maybe 1,000 per night. And that hotel you are paying 2,000 per night. The question is, if you were dropped at, you want to make a budget of these people, maybe they are 5. And they tell you some were dropped at point P, some were dropped at point Q. For you to make a full budget, you must know how many have dropped at point Q. Because by knowing, then you will know how much you need for them, because them where they are going, they are paying 1,000. So each route has got consequences. If you hear all the 5 have been dropped at point P and you're the sponsor, then you're worried because now you're going to spend 10,000. But if you are told, oh, they all dropped at point Q, and then you're happy because you're just spending half of the money you would have spent if they are dropped at point P. So those consequences are the ones that we are studying here. What happens if you are going to 1? The question is, going to 1 from which direction? Oh, going to 1 from left. Then you must know, oh, that road, it's a bad road. Okay? And by the time they reach where they are going, they will need to spend 2,000 per night from left. Okay? What about from right? So from right, you know from right, it's a good road and they're spending less money, 1,000 per night. So the question again is, do they sleep in the same hotel, even if they have used different routes? If they are sleeping in different hotels, it means that the limit does not exist. There is no equality there. Because others will overspend. You would be comfortable if whichever route they use, they will sleep in the same hotel. Then you won't even care about the route. After all, you find them in the same room, in the same hotel. So if they are arriving at different places, then the limit does not exist. If they are arriving at the same place, then the limit does exist. That's the actual idea of limit. So you always need to be careful. Oh, which direction? If there's no direction, you will still question how many options could be there, because some questions will just come open. Find the limit as x goes to 0, like this one. Then you check, oh, there are 2 options as you are going to 0. Okay, if you're going to 0, you can move from this direction or that direction. But the beauty is, whichever direction you use, you are coming to the same point here. So the limit exists. But if you are going to 1, others will be here. Those that will come from left, they will be there. They are in different positions. So the limit there does not exist. The limit will only exist if whichever direction you use, you meet. If as you change direction, you don't meet, then there's no limit there. So it should become taken now.
So,
Yes.
I've understood some now that you've explained, but then I'm still not clear. The x value, how does it come in? The y value, sorry. How is it coming in?
So the y value is the f of it. The cap, the red line. So if I have f of x is equal to x squared, okay, and I have these values -2, -1, 0, 1, 2 as my x, what will be what? So when x is -2, I'll go in f and find y. Where did be 4? So it's 4. So these numbers, the x, they are sitting here. They are controlling y. So depending on the function you give them, they will give you the y value. So when they give you the y values, your job is to study the pattern of the y values. So you are studying two things. You hold x and see what happens to the red line. Is it fixed or it's going somewhere? So if I hold my x from here, I hold my x from here, x is moving on this line. This is x. Y is that one? That is y. The question is, as x goes to 0, where is y going? Y is also dropping from being 1, it was 1 there, maybe here it is 0.5, and it gets to 0. So where y is going is the limit. When y goes, it has been taken there by x. Our response is y has gone there. That is what we call the limit now. So you should, when you want to answer the question of the limit, you should always have two things in mind. Oh, where is x going? So when x goes there, where is f going? Where f is going is your limit. You will always be told where x is going. So your job will be to observe where y is going. And y is always a graph.
So,
Hello.
what if as we approach 1 from the right, at this point at the same 0 is closed, right? Even as we approach 1 from the left, it's also closed at 1. Which value do we consider?
You can't find that.
They can't exist in that way.
No, it doesn't. That one won't exist. Remember when we in topic 2, in functions. In functions, you were taught if this is 1 and you get 2 and 3, 1 gives you 2, 1 gives you 3. Is that a function? It's not a function, right? So one to many is not a function. So you can't be given that. Because all these things we're dealing with here, they are functions.
Okay, I understand, sir.
So then you can check what happens as x goes to 2 from left. So as x goes to 2 from left, it's what? So as x goes to 2 from left, it's 0. So here we have nothing to answer because the question was saying, if you say true or false, you know what is true or what is false? Nothing. Maybe if you want to talk about it, you just have to find the limit. You are saying the limit is 0. If you move from left. From right, there's no direction there. But the beauty is that it's defined as 2. So the fact that it's defined as 2, it makes the limit 0. So if there's no root, you just check if it's defined at that very point. If it is, then that's the limit.
Sir,
Hello.
it says as x is approaching 2, so you're starting from the negative.
From left, next.
We are going to the negative.
You're just starting from the left of 2, not the side the negative.
Okay.
So if you've seen this line, if there's a house here and you are moving from this point, going this side, we say you are moving from the left of the house. If you are moving from this side, if you are moving from this side, forget about the direction of that drawing. So if you're moving on this side, you say you're moving from the right side of the house. That's what we mean by limits. So there's the left direction and the right direction. So it's just a direction. So if you are going to 2 from left, meaning you are moving in this direction. So you come from 1 going to 2. Okay? Where you can't see the direction, just check if it is defined at that very point. This one is defined as x is equal to 2. The function is 0. So you can say the limit from n direction is 0 because it's closed there. Okay, so you have what to think about this line. Better we are slow, but you pick a point. So think about it. and try to see if it will make sense and these were the solutions that we got to take. And after you've done that, with what you have said here and the examples I've given, can you please answer question 2? Because question 2 is giving you different limits of direction. So you look at question 2. So you check the limit as x approaches 1 from right. Where is 1? 1 is here. So you just check what is happening from 2 to 1. Where is it going? So it's fixed. So the limit there is 1. So the first one is 2. Then b as x goes to 2. So x is going to 2. You check from left and from right. So you find from here is coming that dot. From here is coming the same dot. And the same dot is 2. So it's true. As it approaches 1 from left, we check 1 from left is this scale. So it's going all the way up there. We haven't been told what that value is. So we can't say a thing. Unless they tell us that we should use the scale that is 2. If that is 2, then from left, yes, it's going to 2. From right to 1,